Good morning, ladies and gentlemen, here in New York City at Fifth Cloud Expo. Good morning, good afternoon, good evening, wherever you are following this Day 2 keynote out there on SYS-CON TV. We're here, as I say, at Fifth Cloud Computing Expo. Who is old enough to remember that Business Week article that said, Amazon's risky bet? Anyone tell me how many years ago Business Week had a front cover that said, Amazon's risky bet? Do you remember when? 3 years ago. 3 years ago, this was a risky bet. So just think about that as we give it up for this morning's keynote speaker. And he's going to be talking, and this is a good one. So if your brain is not yet awake, you are going to get a shock. The science of doing business in the cloud, spoken by Tony Bishop of Adaptivity. Good luck with this. I love it. Come on, Tony. Oh, you warmed me up.
Yeah, we're good, yeah. We're going to go ahead and shoot it. Little video to wake everybody up here, so watch your screens.
Imagine, for a second, if the design and construction of buildings had just been invented like 60 years ago. Seriously, no one had heard of foundations, beams, windows, anything to do with buildings at all. Okay, now a few geeky kids, for the first time ever, invent a simple little shack. Then other people start building them. But there's no standard types of materials or tools or terminology. Some buildings are really inefficient. Some are awkwardly designed. And while everyone wants increasingly bigger and more complicated buildings, there's no codes or regulations. Just a bunch of cowboy builders making things happen. Buildings weren't invented 60 years ago, but let's be honest for a second. This is really how information technology developed, right? 60 years ago, no one knew what a computer was. Yet computing advanced rapidly without any rules or regulations, or without common terminology or materials. All the while, IT systems became essential to doing business. Well, you can't build a great building without everyone following blueprints, or without guidelines to ensure everything is compliant. But our IT plan is just to find a team of get-her-done cowboys and have them build and patch as fast as they can. As a result, we create IT systems that, if you compared them to a building, they only use 25% of their floors, and they tip with the slightest breeze. When things go wrong, we ask the CIO and his gang to bring temporary order to the town. Okay, these three humps represent the stages of developing an IT system, and here's how much money goes into each stage. Although this hump demands our attention, strategically investing here allows for the operating expenses there to decrease. So let's talk about design. In construction, we've adopted standards and rules based on math, logic, and experience. And we've put all of this intelligence into a tool that lets us design blueprints quickly and reliably. As a result, we could build things that are frankly quite impressive. In the same way, there's math and logic and experience behind successful IT. But here's the thing. There's no tool that leverages that intelligence, so it's left to each IT guy to interpret and design however he knows best.
Ooh la la.
We thought that it was about time that this tool existed, so that your business can quickly and efficiently design blueprints for your IT systems. When there's a problem, you don't have to run and gun to fix it. You now have standards and rules within this intelligent tool. It'll help cost, quality, scalability, time to market, and help you innovate for new problems. To bring this all home, let's take an example near and dear to our hearts. Moving IT to the cloud. You see, the cloud makes some of our normal IT concerns even more disconcerting. Yet we know that moving IT to the cloud is inevitable. So, if designing IT systems for the cloud was compared to, say, designing buildings that could live in the sky, well, you could spend a lot of energy in post-deployment running and gunning trying to get them up there. Or you could start to seriously consider spending a little bit more time on design. We vote design. It's time to take IT to the next level. Prepare for blastoff.
So what do you think, guys? Good way to wake up in the morning? Ladies, too. We had Epifio Studios, which is on the bottom there. They actually are here in the crowd. You think about it, their concept is an epiphany in a video. And when you think about how complex all of us are as IT practitioners and on the IT vendor side or the IT supplier side, you're dealing with very complex ideas, and then people hear this concept of a cloud, and they go, oh my God. So when you sort of look at that, it's a very powerful concept. What we're trying to do is challenge people to think about it in a very simple way, yet very powerful way, and which really leads to the theme of what I want to cover on today. So first of all, I want to thank everybody for the crew that did make it here. Compared to the Oracle keynote, right? I guess this is the real serious, right, people, right, versus those that just want to hear, Oracle's latest and greatest. What I want to do is not take a lot of your time today, but I want to pose to you that it's sitting in your shoes, having been somebody that's had to build and run and deploy IT systems, and the way that you've got to deal with that and the opportunity with cloud. There's 4 things I want to cover today that are key points I want you to take away from it. Point number 1 is that, when it comes to cloud computing for the enterprise, right, it's the intersection of the business processes of the enterprise with how systems are engineered. All right, so the business process intersecting with how systems are engineered. So this is going to be the first point that I'm going to hone in on throughout the morning session here. Secondly, and this is probably the most powerful concept that I can tell you that drives transformation and is the easiest way to link cloud to your business, and that is that IT has become the new supply chain of the business. So when you think of that, right, IT is the new supply chain of the business, related to manufacturing, related to building cars, right? There is a supply chain of materials, goods, and so on, and a manufacturing line, and then a distribution line, right? Quality control line. Well, except in the case of Toyota. No offense, guys. But a quality control line, etc., right? So think about that, because look at how much of everybody's fundamental business is tied to IT today. So the reason a cloud computing paradigm, which is the third key point, becomes the new business delivery paradigm is that this instantaneous availability of service, all right, from an IT standpoint of whatever that business is, the goods, the services, manufactures, services, fulfills, is what you want to be thinking about. And fourth and finally, what you're going to see us pound on, and you think about the topic, is IT's time has come to mature as a multidisciplinary science. So when you think about that, that's going to be the 4 kind of key points that I want to nail for you guys today as we walk through. Everybody can hear me okay? Everybody still awake from the video? Yeah, I haven't put you to sleep yet or anything like that? We're all okay over there? All right? All right, next one. So take a look at this chart. I'm going to use this chart to build with you folks across the next 4 or 5 slides that we're covering. Systems, engineering, so how design, built, and run intersect with business process. I can't stress enough to you that when it comes to the enterprise, you have to hone in on the fact that how the business executes its process to make money, service customers, and be regulatorily compliant if it's publicly traded, all right, directly intersects. So the cloud is now becoming the intersection point, all right, of both of those. So to think about where do I position cloud as a business strategy, it's the execution of the business process in a new type of system model, and then linking that to the old type of system models is where you need to think about that as you go through your designs. So 4 dimensions I'm going to talk about. And I want to really hit on these because we can take from these, right? You think about the study and science of economics has been around for how long, right? Centuries. And it's matured over time. The study of physics has been around a long time. Okay? Management science has been evolving for hundreds of years. And information science has been, according to the video, about, 60 years old, right? If you in terms of a digitized type manner. And who knows what it was like, really, in terms of people studying it before that. Now, I'm only 40 years old, so I'm a little bit off on my history. And if you detect the accent, it's originally Canadian, so, we're not really good at history up there. But that's kind of where we're looking at it. So 4 dimensions that we're going to talk about. I want you thinking this because this is how you link it to critical transformation and why cloud is absolutely imperative and how you can actually make it happen the way business looks at things and designs new businesses. So go ahead. Economics. 2 key lessons. There's the law of price or service determination, right? So that's called demand over supply for those that don't remember for your economics day. You have demand from the business, you have supply from IT, right? The business pays for it. But right now that equation is a hard equation. There is not a science to that equation that says, what could I pay? What is a determinational process of what could I pay and what kind of service could I get? What are my options? Right? So the first thing is you think of a cloud as a delivery paradigm, or what are my options? Can I have it instantaneous? What does that cost me? Can I have it instantaneous with absolute qualities? What does that cost me? The other piece to think about in a formula here, all right, is elasticity. And you think about it, right? Elasticity, you've probably read everywhere and heard when it comes to the cloud, right, is responsiveness or the elasticity of the cloud. It's a key driver, a key design criteria as you go through. Well, when you think about elasticity and the determination of that elasticity, think about the responsiveness. So on one dimension, you're saying, what is it that you're willing to pay for and what do you expect? All right, price service determination. And then the second is the elasticity. All right, what responsiveness or what level of responsiveness are you also accommodating for or would like to have? And in doing so, what would you be willing to pay for it? See, it's a business dialogue. Right? And it's a business dialogue that with the cloud, what cloud's doing is unlocking barriers that can allow you to actually change the way you respond and deliver the service and the elasticity. The issue is there has to be an associated price. Right? You can take advantage of commodity infrastructure and commodity computing, but that's not always necessarily the case. And that's where the fear factor comes into the business folks is they're going, oh, God, does this mean, it's like sometimes I can't actually get to my Google? Right, or whatever. Is that what you're telling me that I'm going to now do if I go to cloud computing? My mission critical, sales or customer facing applications are going to be in that kind of manner. So keep that as one dimension that as you start to have the dialogue, it's around what is that price and service that you're trying to achieve or that you need us as IT to be able to do and fulfill. And then what kind of responsiveness or elasticity would you like us to accommodate? Do you have peak business calendar periods? Do you have exception periods? Do you know certain times of the day business is more busy and other times of the day it isn't? So is there a time dimension to that elasticity? And we'll talk more about that. But they're the 2 keys out of economics that we can learn from economics and apply when we're talking about cloud computing in the enterprise. Management science. Collection of our firm is a bunch of geeks, well, other than our general counsel, right? Who's sitting here, that's why I had to give it to him. But as you look at it, what we need to do is we need to start thinking about that if IT is the new supply chain and you even half buy into that concept, you've got to think about how can I draw and have that dialogue with the business the way they look at. Management science is an accepted discipline within business. Not every business does it well, but there are a lot out there. You'll hear things like Six Sigma and lean business, right? And lean techniques and so on. These are all parts of that management science discipline. But what's key is look at the words that it talks about around supply chain management. Distribution, configuration, right? Logistical trade-offs and optimization. Do we not do that in IT today? We distribute data or content. Right? We distribute applications. We distribute user interfaces. Right? We distribute databases. We have trade-offs. If you want the data, this is the way I can deliver it to you. Right? I have limitations to the data center that you gave me that I got to run this stuff out of. So an optimization is what they're constantly asking us for. So when you're dialoguing about it with the business, you need to be sitting there saying, it's like a management science. It's an end-to-end set of processes that you run, of which there are an end-to-end set of applications that I need to provide that also have to have the associated infrastructure to support this. And guys, I can turn the dial anywhere as you want across that process around the price and the service, the elasticity and the responsiveness, and I can give you the trade-offs. And what cloud allows you to do is cloud allows me to unlock that I can change that delivery model if you want. But we have to have this dialogue that says you have to quantify and qualify, not just say it's got to work or it's got to be up all the time. How many people in here, well, from the business, their definition requirements has got to be up all the time? All right, anybody? Yes? Okay. And if you're not putting your hands up, that means you're not having enough business dialogue. So, and that's not to be offensive, that's to be, guys, the dialogue has to be, this is the way it works. And you want cloud to work. Cloud is there today. You know, we built a 50,000 node, 16 data center globally cloud, private cloud, in 2004 to 2007. You know, when technology was half-baked. You know what that's like? Supporting trading environments and retail banking environments? Drives you nuts. So I have no hair. So when you think about it, but the way we got there, and the only good thing that you can take from dealing with bankers and Wall Street guys is, guess what? They make you have that business dialogue first. Because they're all numbers guys. They also understand how to trade off risk. Now, they're not really good at understanding collateralized debt objects, right? You know, but that's a different story, different topic. You know, we talk about that over a drink. So maybe that's why I'm over on this side of the stage instead of over there anymore. But I want you thinking about it. So economics, management science. You got that? There's 2 dimensions already. Let's go to the third dimension. The third dimension. How many people in here have ever heard of a concept called E equals MC squared? Boy, a lot of people that didn't take any basic physics. I know, it's just the morning. So, energy, mass, equivalence, where C represents the speed of light. All right? So distance, time. One of the things that you've got to do with the cloud is you cannot take the simple answer and be surface to say, well, everything should go to the cloud and everything should be outsourced or everything should be external type of cloud model. It's not going to work, right? If any of you work in any publicly traded organization, you have regulatory demands that says your information, certain ways you do things, cannot move outside of certain geographical regions. You also have the fact that when you're dealing with geographical regions, your data centers may be in one place, or your supplier's cloud data centers may be in another place. So you have to take into account that when you're looking at that price and service, the responsiveness and the elasticity, right? You're looking at what function am I supporting across the business and how it's executing. You then need to take into account the physics. What is the energy that I need to marshal? What is the mass? So, i.e., what is the workload that the business is manifesting in the case of demand, all right, that creates that energy-mass equation that then has associated qualities of where is that data or content, what do I need to do with it, how has that system been built, and how can I exploit a model that alternatively allows me to deliver in a different manner. Everybody still with me, or are we completely confused and it's clear as mud? Yes? No? So can I get a yay or a nay? Yay, there we go. So, it's morning time. So, as you look at that, physics has to become part of your critical equation. I'm not saying everything isn't, but when you start to look at management technologies, and there's some really slick ones out here, all right, that are here today, you got to go look at them. When they start to enable you to package and deploy and run applications and services in different paradigms, you still got to be putting the dimensions of what is the economic model, right? What is the management science model that I'm trying to achieve, or execution model? And then that execution model, how is it I'm dealing with factors of, speed, time, distance? Because all of those have to come into play. Next one. So finally, the final science or component to it is an information science. So you've got to get into it. If you're not into the discipline and you're not into the habit of classifying what are the different types of information and content. How many people in here know that what the number one proliferating driver of data center infrastructure is? Unstructured content. That means videos, Excel files, PowerPoints, right? So on, HTML pages, all right? 50% or more is driven to data center proliferation or sprawl, right? Why do you think EMC and NetApp and Hitachi Data Systems are doing so well? All right? They're growing at 50 to 80% a year in any of these big enterprises. What's driving that? Well, you have regulatory concerns from a management science standpoint. All right? Those regulatory concerns say you've got to keep that data on all your emails for what, 7 years, 10 years for life? All right? Taxes. How many people hate keeping those friggin' files of your taxes for 7 years, right? Same thing. It's happening digitally. So what was happening that way? So as you start to think about that, information science, the of information you're keeping and the way that information is being collected and analyzed, right, and disseminated affects the design and the delivery of how you take with cloud. So these are the 4 dimensions that we've seen in taking and building these. And these are the 4 dimensions that I want you to be thinking about as a science, so that you're talking about the economic model. You're talking about how are we trying to affect the business process from a management science. We're talking about what is the physics that I need to care about. And we're talking about the information science in terms of the types, the regulations, and so on that are going to affect the design of moving to a cloud-like paradigm in an enterprise. So, busy slide. How many people in here have ever heard of a guy named John Porter? Or Michael Porter? Michael? John? Whatever his name is. So, he took the concept in management science and published a thing called the business value chain. And the business value chain was around how you sell, order, service, fulfill, manufacture, support your widgets and your services to your clients. So this is how you make money or lose money and get government bailouts. And this is how you turn around and you deal with the interaction. So IT, you want to know that intersection point we talked about earlier, how systems are engineered to affect it? Here's the way to apply part of that science. So notice the blue is the business process and the red represents the systems to be engineered. Okay? On the left-hand side, you have customers. On the right-hand side, you have suppliers. And then you have some sort of front, middle to back office. It may be called that. It may not be called that. But in the management science discipline and in certain industries, there absolutely is a front, middle, and a back office. Front representing what I'm facing to the client, right? The interaction points to the client. Middle being how I'm taking those transactions, those events, and dealing with them. And the back office being how am I reporting on them. So if you look, you've got in the red big arrows going down operational transaction processing and operational analytic processing. All right? And going in between, I've either got data moving across, so operational data processing, or I have workflow and collaboration that has to occur to fulfill what's happening in the front office. So when you do this, and if you start to have this kind of dialogue, all right, with the business, where are we talking about that business process needing to change the qualities of delivery, the economic model, what is the physics associated with it, what is the informational types that I'm dealing with, and what are the issues that I need with the information? These are the pieces that you need to think about. So let's take it and move a little bit further. Now, very subjective slide here, okay? And I know it's going to create some consternation for some people. Notice that it says private, hybrid, public cloud, okay? Intentionally in putting this there to say the easiest way to get people to buy in is to at least start, when it comes to the business side, a dialogue. Where do they care most on a business side? They care about where I make money and touch a client. So what you do, and what we learned to do, was we learned to say, well, that's going to be my private cloud. I'm going to build it like a cloud, but I'm going to keep it so that that's going to be what's inside. That's competitive advantage, right? That's what makes us special as a company. In the middle office, I may have trusted suppliers, right, that I may use, or trusted delivery partners on applications or information or so on. This is where I'm going to look. It's going to be a mix of a private-public kind of hybrid cloud. And then over to the right in the back office, this is the function where I'm trying to squeeze every single penny out of the cost of that operation as a business person. So if I can take and say those functions are going to be where I'm going to move them to the cloud, at least maybe the processing, because maybe the data there, right, can't actually be external to the organization due to regulatory or Sarbanes-Oxley or any of those types of issues that you have. Again, you start to see the dimensions of what you're dealing with. So look at the bottom under the private cloud. All right? It says supply chain optimization. Right? So we go back to what we talked about before. What are we trying to do? We're trying to optimize the orchestration of that business process across the IT supply chain to be able to deliver the best performance whenever the customer wants, however they want. Right? That's what the business expects. Right? The business behaves that, well, whatever the customer says is what goes. You then have physics. Because the reality is where am I dealing with the movement? And if I'm trying to get best performance, I better be thinking about the physics dimension of this equation too. The third point, information lifecycle management around the information sciences. What information do I need to provide? You know, Oracle's here. One of the things that really makes Oracle different is, besides the fact that the database king, well, app king, and they got everything right now. But is when you look at Oracle, one of the things that's interesting is that they've done some really powerful things around database technology, in-memory technology, and data caching technology. If you're not starting to look at the designs in your enterprise of exploiting data caching and in-memory database technology and how you can do different database strategy technologies around your block-based information, right, that's relational, then you're not going to build an optimal cloud because you're not going to exploit physics in the right manner. You're not going to be able to deliver the information that you're going to need the right way. And you're not going to be able to fulfill the supply chain objectives that you're trying to optimize towards. So, an elasticity on the front end being the final dimension. What are you trying to do? You're trying to remain elastic, right? You're trying to be as flexible as possible to respond to clients' demand on an on-demand, ad hoc, unpredictable basis. Now, you're still going to try to add management science to figure out what are those predictions as best as possible, but you still have to put the elasticity there. In the hybrid cloud, you can see the components and the dimensions of science that become more important. And then also the same when it comes to the public cloud. Public cloud, I would state that in your information sciences, the movement, the security of information, all right, those technologies out there that can encrypt the information, can spread it out so that even if you hack it and get a piece, you can't get it all, so that data in transfer. And then the data at rest on the other end can be so that they can't get to the information. There are technologies and firms out there that are doing that. So that has to be part of your information science that translates back to your IT design to exploit a cloud model. So, go back to the slide. Sorry, thanks.
Sorry to interrupt you. I know you're on a roll there,
Jeremy, did we say the crowd's allowed to ask questions? I mean, holy jeez, right? I mean, God. Now, I did state, right, and I hope I have enough witnesses that I said this slide was going to create consternation. Did I not state that, right? So what you've brought up is an excellent point and an excellent question. Again, it's all subjective to each firm, number one. Number two, it is a multi-dimensional processing problem. But number three, if it was just an economical skew only, right, because there's multiple dimensions of designs that we talked about. If it was an economic model and you were sitting in a financial institution, they'd be saying, friggin' get the back office is cheap, and they outsource the back office, even the business process. So it depends on the industry, depends on the process. I did state that the security of the information in the back office is absolutely critical, where you may want that privately. Maybe you want just the infrastructure computing publicly, depending on how you want to move it. So absolutely, you're right. And this is, putting it into one slide, the point was is start thinking about what are the types of cloud models by function, what are the dimensions of science to come up with that design, and you tailor it and figure it out. Now, there's a little company called Adaptivity. I don't know who they are. I think maybe I work for them, right? That has a very smart design tool that can help you figure that out. But, I'm not allowed to advertise, so I'm not saying anything. Finally, in wrapping up, basic rules. Incorporate multidisciplinary science to doing business in the cloud. We talked about the four of them. Economics, management science, physics, information science. Classify, quantify. That's what the science is helping you do. Related to business processes, related to how systems are engineered and how you need those systems to be engineered. Number two, create an economic model of demand and supply linked to that business process. Put a unit cost, put a volume measure, put a value measure to the business, all right, as you do it. Trust me, you do this, it makes it a lot easier to go win a cloud battle inside the enterprise. Number three, institute supply chain mapping and analysis discipline. If you do not know the complete inventory of all of your systems, if you do not know the complete interdependency maps of all your systems and what they interconnect with today and how they talk and dialogue, and if you do not know the performance and utilization of all those systems as they're behaving on an ongoing and trended basis, you can't build optimal delivery programs. So you have to do this. I cannot stress this point enough because it's simple. It makes your argument objective when dealing with the business because you can say, well, this is the way we do it today. I know I can affect it this way tomorrow. And by the way, here's the economics today. Here's what it can be tomorrow. Profile, workload, and information flow. You have to become students of the workload. The workload is your key to making the business. You control as IT folks, all right? What you don't understand is the power of what you control as IT folks is that it's the workload that if you can show how you can affect that positively or negatively, you then actually reverse the equation with the business. You become the power of leverage instead of being levered all the time. Correlate physics, supply chain management, and workloads. Your design has to incorporate all of those. So what are the physics? What am I trying to execute with it? Where? All right? And what is that workload, which is the demand of the business? Cloud designs must include instrumentation, measurement, and monitoring. If you are not a firm that is strong in enterprise systems management, you need to be. There's a company here called Nimsoft that has one component of the critical type of monitoring that's in here. All right? There are layers. You need transaction monitoring understood. You need performance monitoring. You need power monitoring if it's going to be inside your private cloud. These are all keys that you have to have, and you have to build a logging and auditing discipline to that, right? And an analysis. You've got to learn from that logging and that instrumentation and be able to say to the business, here's what's happening in your business process, and here's how it's executing across the supply chain. One size does not fit all, which goes back to your question. You can't have everything just blocked as a basic. It has to be fit for purpose. A business process, executes with different criticalities and different needs. So you have to make sure that you can design a flexible, dynamic infrastructure that's being orchestrated based on what those needs are when they are happening. So keep that in mind. And finally, cloud designs must include execution management. You have a number of execution management technology vendors that are here today. The runtime people, and I'm not talking IP load balancers. No offense to Cisco and Juniper and F5 and everybody else, right? But you have to be able to look at that workload. Where does workload occur? Workload occurs in app servers, web servers, messaging environments, right? It's user-driven, it's event-driven. You have to have tools that monitor and measure and can adjust. Look at arrival rates of messages coming into the queues. Look at the depths of the queues, right? Set policies around that tie back to that business process and those requirements. So with that, I want to say thank you. I hope it wasn't too bad for you guys this morning, first thing. And I hope we opened your mind up and shared with you some good thoughts. Thank you very much.